phi 1 of y, phi 2 of y. Okay. So you can look at the picture and you can even think that, okay, which method is going to be useful. Can I go other way around? What if you want to do with respect to y first and with respect to x afterwards? So in such situation, this is the better recipe actually. Take it. But sometimes, okay, let me write this situation. Okay, the picture is not going to be good. It's going to be a bit misleading, but it will be enough to at least make some sense of things actually that what I would like to do. So imagine I have this x-axis and y-axis. Okay. And imagine I have this, really a circular, maybe some kind of ellipse or some kind of a region, this which is type 1, type 2 both. Okay. So, and I want to do integration here. So I have two choices. For example, one choice could be split it in this manner. Okay. With respect to y, I know that it only exists here. And with respect to x, I can say that okay, these are the two curves in which I'm going to always stay actually. So this curve is what, let's call it a phi 1 of y and phi 2 of y. Okay? But I can see this picture from another perspective as well. So I have, say, the same picture, but look at it from this perspective actually. Okay? So I can say that my x lies here and above is that is psi 1 of x, something like that. Okay, it looks like a circle, but could be any picture which has this kind of properties. Okay. So if I'm writing this, what I'm saying actually. Okay. So if I want to, for example, integrate, so something is defined on such kind of a domain actually, and I want to, that something is say f. And I want to integrate it. So how should I integrate? Dx dy or dy dx? What would be the better way for me? It should be dx dy. Okay. Then y goes from, say, some c to d. So let's call c to d. And f of x goes from some phi 1 of y to phi 2 of y. But I want to do what now? I want to change the order of integration. In other words, I want to write the same, but with respect to say y first and with respect to x. So in other words, I want to look at the picture from this perspective. So I'm changing the perspective. The picture is there, the area is going to same, everything is going to stay same. The only thing is that I'm just changing the perspective. So I'm going to say this is same as, so x, so I know that x goes from say x equal to a to b, x equal to some b, so a to b. How about y?
Follow x to phi 2.
So psi 1, x 2. In other words, wherever I am moving in this region,
between these two curves.
okay, so I'm going to have phi 1 of x minus phi 2 of the real thing is to make sense of the given thing. Maybe you will be using such kind of things when you are learning probabilities. Have you started with the joint probability distributions? Not yet, but you can learn it. Because there, right, at least continuous time to kiya hoga. Continuous time random variables. In other words, how you compute the probability that x is a continuous time random variable?
Continuous
then you integrate the things.
Yes.
If you have a two-dimensional random variable, you need the joint, you need to do the double integral. So f of xy is going to be the joint PDF. That will also be useful. ठीक है? Think about this picture. Imagine someone gave you this picture, okay? Something like this. What would be the best way to integrate? What would be the best way? Yeah, that's, for example, if you want to integrate this, so some function is f of x by, so if I have, for example, dx to dy, okay? So how can I integrate it?
dy जो फिक्स हो गया था
dy fixed होगा, so y is fixed.
Yes, sir.
From this to this, we say y equal to a to y, yeah, y equal to 0 to say y equal to say 5, so 0 to 5. But how about x? Now what do you have to do? Think in head that you have to just, you know, kind of in your head move the lines, okay? You know, within that region. Or then see that whenever you are moving, for example, horizontally, you are going from where to where?
X equal to 0 to
You're going to say x equal to 0 to this line, whatever this equation has actually. You're going to say it's x equal to 0 to this line, maybe, you know, x equal to something like that. I don't know.
X or Y.
You know, some kind of a y axis. X that depends on. Take it? But someone says, no, but compute this dy dx. I want to integrate in this manner actually. So what should I do? So x to chale, ठीक है, I have this, say 0 to some number, you know, x or maybe whatever, 5 chale, doesn't matter, ठीक है, doesn't matter. Now how about y now?
y होगा तो सर x डिपेंड कर रहा होगा
अब is the trouble. Now if I am moving along y-axis, okay, nothing is changing here, nothing, but this point is crucial. After that, so up to this time, my y is going between these two lines, but after that my y has started going between from y equal to 0 to this curve actually. 0 to this curve. So what should I do?
We will divide it in 3 portions.
Yes, you should split this region. So you don't have to be Einstein to learn it actually. This is just, so if you have dy dx and you want to integrate say f of x y, okay. So you're going to say here I am between say y equal to 0 to 5 and x is also 0 to 5. So this is like a square region. Okay. And 0 to 5 and then 0 to something that depends on
Y, X, Y,
x, so y of x, something like that. And then integrate it. F of x, y. Do that dx. Easy?
Yes.
ठीक है? यही करना है. Let's do some examples, concrete examples. ठीक है?
You have a book of part in it?
Huh?
You have a book in it?
No, that's not part of the book. Find what else. इस 0 to y of x ले रहे हैं.
उसकी X की क्या?
I was like, okay, this point is say, okay, so that's y equal to 5, I know that, और ये क्या है, so this is some point, I don't know क्या point है, let's give it a name, say it's 3 for example, x equal to 3, so इसके coordinates क्या है, 5 comma 3 comma 5, okay, and then I can find an equation of line actually, because this is 5 comma 0, ठीक है,
तो यहाँ पे हम 0 to 5 टोटल ले रहे हैं ना x,
Okay, this is a good point. I shouldn't take 0 to 5 here, but this is a very good point. 3 to 5.
तो यहाँ पे 0
0 to 3 होगा।
0 to 3 लेना चाहिए। ठीक है, स्प्लिट करते हुए you have to be careful. ठीक है, इसे कहते हैं जागते हुए रहना। वरना तो गाँव में सुधर कर संकांच होता है सही। ठीक है, पांच का दे तो बात। वो खनियाँ कुछ भी पढ़ाया भाई। ठीक है, ठीक है, but you got the essence actually. ठीक है, you know, I can do hundreds of examples actually, but it's of no use in the sense that you just have to look at the picture and decide what to do. That's what the only thing that you have to. For example, let me just do one concrete example and then. Okay, so here's the thing. What should I do? Should I do a difficult one, easy one? Okay, so here's the thing. Let's do the easy one. So let's only change x equal to 0 to x equal to 3 and y equal to say x square to 9. In other words, 0 to 3, x square to 9, and I have x cube, y square and dy dt. Okay? This is not important at the moment here. Okay? This is not important here. And I want to change the order of integration. I can calculate it directly, it's not a difficult integral. Okay? This trick would be useful when you have kind of integrals where integrating with respect to one variable is difficult actually. Okay, then you can change the order, okay, and then integrate it. Okay. For example, instead of this, I give you say, I give you e to the y square integrated form. You're gonna say what? No, I can't do anything with it actually. Okay, but if they change the order of integration, you're going to see a miracle happens actually. Okay. So first of all, what we need to know is that what does this region represent? That's the key thing that you have to basically do always. What is this region? So the region says x is 0 and x is 3. So 0 and say 3. Okay. And I have y 9. So maybe y is somewhere here 9.
Yes.
Another is y equal to x square. So how does y equal to x square goes like so?
Yes.
So the question is what region we are talking about. If this or if this, what region?
So above it.
It's above region. Sure?
Yes.
Because we are going to one. Okay? So at the moment it looks difficult. I can't integrate. I don't know how to integrate e to the y square with respect to 1. The order of integration can do miracle. Now let's write say limits on dx dy e to the y square. So from where y is going to go? So let's put limits on y. So y always changes from 0 to 9. 0 to 9.
Yes,
Okay, starts from 0 goes to 9. So that's pretty much obvious. How about x? X and rather horizontally how you are moving actually. So when horizontally I am moving, I am going from x equal to 0 to this curve, 0 to this curve, 0 to this curve. Nothing is changing until the end actually.
0 to x square.
0 to x square.
0 to y square.
Oh, y square.
Y square.
Y is equal to x square. 0 to square root of 1 minus
1 minus.
No, sir, it's
So see, I know y is x square here. The question is what would be x? Square root of y. Okay, square root of y. So you have to do 0. You're starting from 0 always and always going to square root of y. Square root of
x.
y. ठीक है. Square root of y. ठीक है. And now it should be easy peasy. Why? Because think about it. Now, like if this is like a constant, so integrated with respect to x, and then substitute the limit. Okay, maybe the integral will be in bit better shape as
It
compared
will
to
be equal to y, so it will be easy to maintain.
maybe. ठीक है? समझ आ रही है? So the real thing is looking at this. So you have to only be careful when you have a region that is changing its behavior actually. So now that I have the same curve 0 to 3, but this time it okay. Square root of x will be dominated by. So in other words, I want to talk about such kind of a region. Okay, so I have say maybe this curve and this curve. Actually, I'm talking about this region. Okay. So in other words, okay, so say imagine this is y equal to some f of x, and this is y equal to
G of x.
some another f2 of x. And I want to integrate, for example, this with respect to dy and dx. So for x, I know that these are fixed values. Okay. And for y, I'm always going from this curve to this curve. Okay. But if you're going to change the order of integration, dx dy, then you're going to say, with respect to y, you are going from this point to this point. While horizontally, you're going from this curve to this curve. But for this, you have to invert it actually. So x equal to f2 inverse of y2. Okay, so proper limit is going to be, so starting from f2 inverse and ending at f1 inverse of y. समझ आ रही है ना बात?
Yes.
So that's what we have to do. ठीक है? I hope it's making a bit sense of it. Okay, we're going to start next class.
So you have to these notes.
हाँ?
You have to these notes.
ये वाले इसमें कर दो। इसमें कुछ